Hi, welcome to another Level 3 integration video. In this video, we finish up our discussion on area under a curve. Alright, well we're getting straight into an example. Our job is to find the area of the orange shaded region using the function y equal to x squared. So the graph is a parabola, y equal to x squared. But notice this time, the area we're trying to find is between the graph and the y-axis. Not between the graph and the x-axis is what we're commonly used to. So we're going to have to do a little bit of a trick here to sort this one out. And the trick, once you understand it, shouldn't be too hard to understand. And it's as simple as this. We're going to swap the x and y over. So we're going to, instead of writing y equal to x squared, we're going to write x equal to y squared. Now what that does is it tricks the function, the graph, to thinking that the x-axis is the y-axis and the y-axis is the x-axis. So we end up with a function that looks like this. It's the same function, but it's on its side, pretending that the x-axis is the y-axis is the x-axis. And therefore, the area that we're trying to find is still between the boundaries of 3 and 6. And now we can carry on as if it's normal. But before we do that, let's just take this function x equal to y squared. Let's write it around the other way first. Let's go y squared equal to x. So I'm just putting the y squared first. And now we've got to get rid of the squared by taking the square root. So y is equal to the square root of x. Now I could put a plus and a minus here, because you should know that when you take the square root of a number, we can get a positive and a negative value. If we just focused on the positive value, we'd get a function that's just positive above the x-axis. When we have x a positive and a negative, we have a positive and a negative above and below the x-axis. Now in this example, we don't need to worry about the negative square root of x, because we're worried about the area that's above the x-axis. So we're just going to focus on the positive square root of x. So to calculate the area, now we're just going to work out the integral between the boundaries of 6 and 3 of the square root of x with respect to x. All right, well we know the square root of x is equivalent to x to the power of a half. So now let's do our integration. Let's add 1 to the power of a half to get 3 halves and divide by the power of 3 halves. Remember, when we divide by 3 halves, we multiply them by the reciprocal. So the 2 will come up to the top and the 3 will stay on the bottom of the fraction. So we end up with 2 times x to the power of 3 halves divided by 3 plus c between the boundaries of 6 and 3. Right, now we're ready to substitute. We substitute in the upper boundary into this function, and we substitute in the lower boundary into this function, and we subtract the two numbers. Remember what's going to happen with c. C minus c will disappear, so we're not really worried about what the value of c is. So we're going to grab our calculator and calculate this. Now just be careful please, because when you have numbers raised to the power of a fraction, I prefer to put them inside brackets. So I'm going to go 2 times 6 to the power of bracket 3 over 2, close bracket, and then I'm going to divide 3, and I'm going to do the same with the lower boundary, 2 times 3 to the power of bracket 3 over 2, close bracket, all divided by 3. Right, well the answer you should get is about 6.33, and I'm going to round the answer to 2 decimal places. Right, well that's it. It's a cool little trick. Just remember, if you're ever faced with finding an area that is backing onto the y-axis, this is a little trick you can use by swapping the x and y over. Great, thanks for watching.